All right, today we are going to chat a little bit about the title of this section, 1.7, is more with derivatives. And really this whole class really is focused on the derivative. But let's just look at a couple things here in 1.7. So 1.7 more, and again, I expect you have, oh, my handwriting today, have read this section already. So I just want to do some examples today. So I don't want to make this too long on you, but let's just do some examples. So the first example I want to do is I just want to talk about taking derivatives that are not with respect to x, that are with respect to other variables, which is okay. So, maybe we have something like this. So, whoa. So our first example, find the first derivative of each function. So I'm going to be a little lazy and just say find the first derivative. Okay, so what if I had something like y equals, the big idea here is that I don't always have to derive with respect to x. So maybe y is a function of, let's say, s. So I have 3s squared minus 4s plus 5. And so in this section, what they talked about was some different notations for this. So let's find the first derivative. We'll call this a. We'll do a couple of these. And so to find the first derivative of this, I can either put y primed, so that's one way to write the derivative. Another way that they were talking about writing is I can take the derivative of y, and then on the bottom I would say ds, because that would be the derivative of y with respect to s. Y is a function of s, so we're looking at what is the rate of change of y as s changes. And of course, we would use our handy-dandy power rule to do that. We don't have to do the definition of the derivative anymore. So what if, there are different ways that we can write this. Sometimes in mathematics, you'll see that like x is a function of time. So maybe we have something, like 3t squared. I always do that. I don't know why I always do like the same function. Let's do something different. How about 4 square root of t plus 1 over t. So again, I want to take the derivative of this with respect to t. We could put just x primed. That would be fine. Another way, again, I could write that is dx dt, correct? So we'll actually see this dx dt come up when we do related rates. And before I actually take this derivative, I know I want to use the power rule. So I'm going to rewrite this with exponents. Okay, and now I'm ready to take the derivative. So if I bring down this, if I take this 1/2 and I multiply it by 4, well, what is 1/2 of 4? That would be 2. So I'm going to have 2. If I take a half away from a whole away from a half, I get a negative 1/2. And then I'm going to bring that negative 1 down, of course, and I'm going to take 1 away. So you could leave it like that, or eventually we're going to want to maybe simplify these a little bit. So this would be 2 over the square root of t. That's what that negative does, minus 1 over t squared. I hope that makes sense. So that's just some new notation. Not anything super new when it comes to actually taking the derivative, but the notation might be new. One thing that could be new for you is this idea of the second and third derivative. So let's look at find the second derivative of each function. So in the book, again, how do we find the second derivative? Well, we just take the derivative of the first derivative. So a couple ways we denote this. So if I had f of x maybe equals x cubed minus 4x, maybe all to the 4th power. Okay, I want to use the general power rule to take the derivative of this. So to find the second derivative, I need to have the first derivative. So I'm going to take the first derivative, obviously, and I'm going to take this form and I'm going to bring it down. I need to make one change here. Sorry about this. Will you guys please get rid of that x right there? When I go and, okay, there are people outside my office talking. When I take this derivative, oh, we can't do this one. Yeah, so let's just look at Hold on 1 minute, guys. Sorry about this. This is what I get for just like making these up as I go along. But I am forgetting that we don't have all the tools we need to have. I'm sorry about that. I used to hate it when my teachers did this. So let's do something. The problem is we're going to get a product in here and we don't know the product rule yet. Okay, let's try this. So I want the second derivative of this. So I'm going to do the general power rule. So remember, this is my kind of inside function. This is my outside power. And so I need to bring that power down. Remember, we leave that inside and take one away. And then we need to multiply by the derivative of the inside, which is 3. And then I am, of course, going to simplify this because I know, well, we want everything simplified anyway. All of the final answers that you give me need to be simplified. But the bigger thing is I know I want to take the second derivative. So I want to make sure everything is simplified. So we're going to come back to here now, and I'm going to take the derivative of this. So I'm going to bring the 3 down, multiply it by the 12. That gives me 36, I think. And then I still get the 3x minus 1. I still take 1 away. That's what the general power rule tells me to do. Leave the inside, take 1 away, and then don't forget to multiply by the derivative of the inside. So my final answer, f double primed, or what that means is the second derivative of f. Oh, and that's a number, I think that's 108. Probably. I think so. And that's my final answer here. And we'll be doing stuff with the second derivative later on in this class, but for right now we're just practicing taking the derivatives, and then we'll move on from there. Okay. The next example that I want to do, well, let's do one more of these actually with a little bit different notation. So one more. So what if we had something like y equals, how about x squared plus 1 all divided by the square root of x, just for the fun of it. And I want to find the second derivative. So again, the first thing I want to do, remember we did this in the last section, I have x squared plus 1. I'm going to rewrite this x, square root of x down here as x to the negative 1/2. Then I'm going to multiply this through because I cannot take the derivative of this times the derivative of that. That's why up here when I was thinking of having that x cubed, I would have had a 3x squared out here, which then we wouldn't have been able to do it because we don't actually know the product rule yet. We are going to soon, but we don't know it quite yet. So if I multiply this through, remember this is x to the 4/2 basically. So this, I add exponents when you multiply like bases. So here is what my function is. In a nicer way, I wanted to write that so I could use the use power rule. So let's take the first derivative. So dy dx, I'm going to bring the 3/2 down, and I'm going to take 1 away. So 3/2 is 1.5. You take 1 away, you get a half. Bring the negative 1/2 down and take 1 away from a negative 1/2. That would give me a negative 3/2. Okay, so there's my first derivative, and now I'm ready to take my second derivative. I really wanted to do this, we'll do this over here, because I wanted to show you the notation. This is the notation for the second derivative, so if you see anything like that, that's what that means. And then I can take the derivative again, bring the 1/2 down, so I would have 3/4. Subtract 1, x to the negative 1/2, bring the negative 3/2 down and multiply. So that would become a positive 3/4, x to the negative 5/2. Now, one other thing with this one, and let me make us a little bit of room here. When we look at this, so I want to go back to this a little bit, and I want to think about what I would do maybe to simplify this a little bit. So let's rewrite what we have. Okay. So we have dy dx equals, the second derivative. So we had 3/4 times x to the negative 1/2. So I'm going to put that on the bottom. So that would be, Sorry, it is early morning and I have not finished having all of my coffee yet. So I'm sure there's some of you out there who can sympathize with me. So I need to make sure that next time I try and record a video, I have my coffee. So I am just rewriting this. This is going to look a little bit weird, but I'm going to put the other layer on. I'm going to see what's going on here, because what I want to do is I want to show you what would happen if we actually put in some numbers. So this would be 3 over 4 root x, and then plus, we also had 3, right? Or 3/4, excuse me. So I would have 3 over 4, and it was x to the 5 halves. So x to the 5 halves can be written like this, x, the square root of x to the 5th. The whole reason I want to do this one for you is because I want to show you, and I know you've read the book, but I just kind of hate that I'm not there to walk you through this. What if I said, okay, I want to take this second derivative right here and I want to evaluate at a number. Let's just do 1 because that'll be nice and easy. What this line means, this should be a vertical line, just pretend. What this line means is take the second derivative and evaluate it at x equals 1. So all that means is plug in 1 for x. So I hope that makes sense. I know they go through that in the book with you, but I kind of hate that I'm not there to make sure everything is okay. But this, of course, the square root of 1 is 1, square root of 1 is 1, 1 to the 5th is 1, so I have 3/4 plus 3/4, which is 6/4, which is also known as 3 halves. I hope that makes sense. Okay, I want to do one more example, and then we'll call it good. So let's clear that all out. So the other thing that you kind of want to pay attention to in this section, the other really big idea of this section is that the derivative gives us a rate of change. And so there's a box on, I think it was on page 107 or something, about the rate of change. And so another big idea is that the derivative at some point A is almost equal, about equal to the function, basically a change of what would happen if I increase my x value by 1. So if you look on page 107, I think they have oh no, not 107, excuse me. Yeah, 107, top of 107. If you look at 107, it kind of talks about this. And there are some other things that we need to define. And I know you've already defined this in your notes because you've already looked at the book. But I like how I keep saying that because I want to believe that you have. Another big concept of this idea is the definition of marginal cost and marginal revenue. So this idea with marginal cost and marginal revenue, also marginal profit and marginal profit. So marginal cost, marginal revenue, and marginal profit. All this stuff is saying the marginal cost, so at a production level of A, all right? So all of this is at a production level of A. So you guys are business people. If I have a business, let's say I'm selling Math is Fun t-shirts, and I'm looking at what is my cost to produce so many t-shirts, right? 100 t-shirts or whatever. What this marginal cost will give me, if I look up here, let's say again I'm at 100 t-shirts, right? If I C primed of 100 then is basically, if I look at this function right here, C of 101 minus C of 100. What the marginal cost gives us is it gives us an estimate of the cost to make one more shirt or to make 101 shirts. Okay, that is the idea of marginal cost, marginal revenue, marginal profit. The derivative gives us a nice way to just estimate this change. If I want to increase production by 1 unit, right, what does that do to my cost? If I want to increase production by 1 unit, what does that do to my revenue and what does that do to my profit? And the derivative is a way that lets us estimate what that would do for each of those. I hope that kind of makes sense. You should look at the the fun sheet. The fun sheet has some examples of this. Example 5 in your book is going to be very, very important because one of your homework problems is example 5. Example 5 is on page 107. Everything is on page 107 apparently. But what I just want to do is I want to do one example with the marginal cost, but we are going to be coming back to this idea of marginal cost, marginal revenue, marginal profit. Again, what this is asking is what would the change be, or what is the estimated change in cost or revenue or profit if I increase production by 1 unit? That is what you need to remember from that. All right, so let's look at one example, because I always, when I go to make these videos, I always tell myself that it's going to be under 15, and then it's never under 15. So the weekly cost of producing, I think I just made this example up, X military tanks. And I don't think my numbers are going to be quite right, but we'll try this, is given by. So I'm doing an example that's pretty easy. C of X equals 10,000 minus 90X, and then minus 0.05X squared. Okay, so what I want to look at, and this is cost per tank, okay, and this is, we could just say, if we're military tanks, maybe this is in like thousands of dollars probably. Okay, I imagine military tanks are quite expensive. So my first example here is I want to evaluate C of 500 and C primed of 500 and interpret. Don't you love that when math teachers say that? Interpret. I don't know if I spelled that right, but that's okay. I'm a math teacher. It doesn't matter. So what I want to do is I want to evaluate C of 500. I want to evaluate C primed of 500, and I want to interpret the results. So C of 500, what does that mean? What would we do? Well, that just means you want to evaluate this function at 500. So I'm going to put a 500 here, and I'm going to put a 500 here. And I'm not going to, just for time-wise, I'm not going to show you that, but I just want to put in the 500, and I want to just evaluate the function. That's all that's asking to do, okay? And so if I put that in, oh, I guess we're not in thousands of dollars. Sorry about that. So I look at my notes. We're just in dollars. And I think, well, we'll just, I don't know about military tanks. We'll just do thousands of dollars right now. So 42,500, which doesn't seem quite right because I don't think it would only cost us $42,000 to make a tank, but we'll just go with it. That's okay. So I have 42,500. If it had been thousands of dollars, I would multiply this by 1,000. So that's probably more realistic, $42 million. But let's just say 42,500. So the cost to produce 500 tanks is a total of $42,500. And now to find C primed of 500, well, I need to find C primed of X. And then evaluate C primed at 500. So I'm going to take the derivative of this. Derivative of 10,000 is 0. Derivative of negative 90X, that's just a negative 90. Bring the 2 down, right? I would get minus 0.1X. And then if I take the derivative and evaluate it at 500, okay, what I end up getting is a negative 40. Okay, so if I look at this, oh, excuse me, this should have been a plus up here. Sorry about that. I didn't think we should get a negative. We wouldn't expect our, well, I guess sometimes you could think about costs going down, but in this case, that doesn't really make sense. So excuse me about that. Man, this lecture. Next time I record your lecture, I'm drinking more coffee. Promise. So I get 40. So let's talk about what that $40 means. Now, again, we could interpret this. Now I want to go back and call that thousands again, but that's okay. This $40, this is the marginal cost, right? I'm going to finish this and then I'm going to stop talking and go drink my coffee. This is the marginal cost. So again, what does this mean if we interpret this, right? So this is the cost to produce 500 units or 500 tanks, right? $40, that's the marginal cost. What does that mean? We want to interpret these results. So at a production level, of 500 tanks per week, right? Because this is the weekly cost. 500 tanks per week. The costs are increasing at a rate of 40 per tank. So $40 per tank. That's what that means. You have to make sure you know you have to make sure that you understand what these means. The other way to interpret this is if I wanted to raise my production to 501 tanks, this $40, right, would tell me it would cost another $40 to produce that 501th tank. All right, I am at 20 minutes and I bet I have lost you guys. You are done watching this. So there's usually a part B. What I would do, go look at the fun sheet. It's posted in Blackboard. In the fun sheet, the very last one is very, very similar to this. Also, make sure you look at example 5 on page 107, especially to do your homework for number 46. All right, thanks, guys.